In this video, we're going to be taking a look at the equations of circles. So this is section 12.5. So I've written here the standard equation of a circle, and it is x minus h squared plus the quantity y minus k squared equals r squared. And the important thing about a circle is the center and the radius, and from this equation we can easily see the center. It is h comma k. So this is the center that we're going to pick out of our equation, and notice I don't take the negative sign with the variable. That'll be true when we pull the center out of equations. We're going to write it with a negative sign, and then we're going to use the h and the k value without the negative, okay, without that subtraction sign. And then I want you to notice that the radius over here is the square root of r squared. This is a squared term, okay? So to find the radius, you need to take the square root. So let's go ahead and work through some problems here. It says, write the standard equation of each circle. So underneath the given information, I've written the standard form, the generic standard form, so that we see it in front of us. So when we write the standard form of each equation, we should find our h, our k, and our r values and plug them in. So up above, we said that the center is h comma k. So if I know my center, I know my h value and my k value. So in this case, my h value is this first guy right here, is 2. My k value is -8. My r value is 9. So all I'm going to do is I'm going to replace h, k, and r in this equation with the values I have. X minus 2 squared plus y minus a -8 squared equals 9 squared. And then if I have double signs, I can't leave double signs, so I eliminate my double signs to get my final equation. X minus 2 squared, y plus 8 squared equals 81. And this is the standard equation for my circle. My next example, let's pull the h and the k values out. H equals, this is h, this is k. H is -6, k equals 3, and r equals the square root of 3. So let's go ahead and plug those in our standard generic equation. H is -6, k is 3, and r is radical 3, and I can't forget that squared there. So I'm going to get rid of my double signs again. Minus a minus is a plus. Y minus 3 squared. And when I square a square root, I just get what's underneath it. And there's my equation. Okay, so the last example of this type, this is my h, this is my k. So h equals 0, k equals 3, r is 7. So when I plug that in, I'm going to get x minus 0 squared plus y minus 3 squared equals 7 squared. And I know when I take 0 away from anything, it's just this. So this, I don't even need parentheses anymore. It's just going to be x squared plus y minus 3 squared. And when I square 7, I get 49. Okay, the next set of problems is to write the equation of a circle with a given center. So they give us our h and k values, and that passes through the given point. Well, they give us the point because they haven't given us the radius. We're going to use the center and the point to calculate the radius. So before I get started, I'm going to just write my h and k values down over here. H is -2, k is 6, and I don't know what r is. I'm just going to leave that blank for right now. So how do you find the distance between 2 points, right? If I have a center here and I have a point on my circle, this is my radius. So I'm given the 2 coordinates of those points. I'm just going to use my distance formula. So my radius is going to equal I'm going to do this as x1, y1, x2, y2. So I'm going to say negative 2 x2 minus x1 negative 2 squared plus y2 10 minus the 6 squared. So I'm going to get rid of my double signs here, and I know negative 2 plus 2 is just 0. 10 minus 6 is 4. So what's the square root of 16? It's just 4. My radius is 4. I was just using the distance formula with the center and the point. So now that I have that, I'm just going to plug, right, my values into my standard equation. So I get x minus a minus 2 squared plus y minus 6 squared equals 4 squared. So I'm going to get rid of my double signs. X plus 2 squared plus y minus 6 squared equals 16. And there's the standard equation. Okay, let's do a couple more examples of these. All right, so we need our h and k values. So let's write those down here. K is 5, R we don't know. So I'm going to call this x2, y2. This is going to be x1 and y1. So when I find my radius, I'll use my distance formula. 0 minus 6 squared plus 0 minus 5 squared. So 0 minus 6 is negative 6. Negative 6 squared is 36. 0 minus 5 is negative 5. Negative 5 squared is 25. So I get the square root of 61. And I don't think the square root of 61 reduces. So my R value is the square root of 61. So now I'm just going to plug my values in. X minus h is 6. Plus y minus k is 5 squared, equals the square root of 61 squared. And I know when I square a square root, I just get what's under the square root. So I get 61. Okay, last one of these types of problems. So my h value, my k value, h is negative 10, k is negative 5, and I have no idea what r is going to be yet. So I'm going to say this is x2, y2, x1, y1, and then I'm going to use my distance formula to find r. So I get a negative 5 minus a negative 10 squared plus a 5 minus a negative 5 squared. Okay, so remember to put these in correctly. Okay, there's a lot of 5s in this number, both positive and negative. Make sure you have them in correctly. All right, so I'm going to get rid of my double negatives here. So negative 5 plus 10 is 5. 5 squared is 25. Get rid of my double negatives here. 5 plus 5 is 10. 10 squared is 100. So now I have here, I have an r value of the square root of 125, which, by the way, I'm not going to simplify, because when I put it in the equation, I'm just going to square it. So here I'm going to replace h in the equation with a negative 10. I'm going to replace k in the equation with a negative 5. And that's going to equal the square root of 125 squared. And you're going to see why I don't reduce that radical, because it makes it easier to not reduce it. So I need to get rid of my double signs. So I have x plus 10 squared plus, get rid of your double signs here, y plus 5 squared equals, and when I square square root, I just get what's underneath it. final equation. All right, so now I have a couple of examples here. It says find the center and radius of each circle. So I'm going to start off by writing the standard form of a circle underneath here. And I want you to notice that the very first thing, I don't have negatives here. This one is good, right? Minus, minus, but the first one isn't. So I'm going to write it in terms of a minus. So I know to get a positive, I can subtract a negative. Okay, so whenever you have a positive, you need to turn it into a subtraction of a negative. Okay, what's squared is 16? 4 squared is 16. So now when I write this, you can clearly see what h and k are and what r is. So my center is going to be -7, comma 5, and my radius is 4. Okay, let's do that again. This is x minus h squared. That matches up really nice. Plus y minus k squared. This does not match up. Equals r squared. So now I need to go ahead and rewrite that addition in terms of subtraction. So I can find my k value. Y minus a -8 squared. What squared is 100? Well, 10 squared. Okay, so let's go ahead and compare that to our standard form so we can find our h and k values. So I would say my h value, so here, remember, we're not taking the minus sign, right? We're leaving this. Okay, so h is 3. So my center is h comma k. H is 3, k is -8, and my radius equals 10. All right, so this is going to be the last one, but I'm going to erase this 36 because it is a perfect square, and I want to show you one that isn't a perfect square. So let's just pick 17. How would you do it with 17? So I chose this one because it doesn't look anything like the standard form of my equation. Oops, that's a minus. All right, so we're not actually subtracting anything from x and y, and 17 is not a perfect square. So what do? Well, I can always subtract 0. Okay, so if I'm not subtracting anything, right, I don't have that subtraction, I can always subtract 0, right? Here again, I have my y squared term, and my y squared term, I need to have been subtracting something from it, and there's nothing being subtracted. So I'm going to subtract 0. And 17 is not a perfect square. So I'm going to rewrite it as the square root of 17 squared. So when I compare it to my standard form, it's easy to pick out my h and k values. H is 0, k is 0, r is going to be the square root of 17. So my center is going to be 0, 0, and my radius is going to equal the square root of 17, and that's how I would like you to do your homework.